Hi guys. Uh, this is the Heat of Fusion lab for General Chemistry 2. The audio sounds a little different because we are re-recording the audio, but that's just due to some technical issues we had in the recording. Now, this particular lab has two main purposes. One is to give us some practice with working calculations involving system and surroundings and the heat flow involved between them. And it also gives us an opportunity to practice some of our lab skills. So we are going to be working with pretty easy techniques and also some pretty benign substances. So in this case, we're going to be working with water. So we are going to be looking at the heat of fusion of ice and taking some measurements and working calculations to verify that the heat of fusion is what the literature says it is. To do that, we are going to be using a calorimeter. And we're going to be using a basic one made out of a coffee cup and lid, as you see here. The styrofoam is a very good insulator. It ensures that there's not going to be heat leaving the cup and also not entering the cup. The probe that you see going in through the top, that is a temperature probe hooked up to the computer, and that is going to allow us to monitor the temperature in real time. So we don't have to babysit this and reread the temperatures every time. It's just going to read all of the temperatures for us, and we can pick the highest and the lowest for our measurements. Now, we are going to be using ice, which we already have on hand, and water. And the amount of water that we use doesn't actually have to be measured in terms of volume. I am going to use a graduated cylinder to make sure that I have a decent amount, but it does not, again, have to be measured in terms of volume. We could use the volume measurement and density to get the mass of our water so that we can use it in Q equals mc delta T to figure out the amount of heat it loses. But we get more significant figures if we use the balance to measure the mass rather than the graduated cylinder. Now I'm going to go ahead and move the tip guard up to the top so that it actually works to guard it from breaking. And then I'm going to put in the water. So it's going to be about 75 milliliters. It does not have to be a measured exact amount. So I'm just going to take the lid off of the bottle and then pour it in. So this is going to be the water that goes into the coffee cup initially. This is going to be our quote unquote surroundings. That is going to feed heat into the ice, and then the ice is going to absorb that heat and be our system. So before I put the water in, I'm going to measure the mass of the cup and lid while it's empty. And then, after I've done that, I'll pour the water from the graduated cylinder into the cup and measure the mass of those. So I'm going to go ahead and take those over to the balance. I'll have a still shot of the masses for you to read in just a moment. All right, so I have measured the mass of the cup and the cup with the water in it in grams. The water is still inside of this cup, and it's the water that is going to be the surroundings that feeds heat to the system that I'm going to be putting in here later. Now I'm going to put the temperature probe through the lid first so that I don't worry about puncturing the bottom of my coffee cup. And I'm going to set it down in there. And it'll be set up like so. And you can even swirl the cup so that you have good contact with the water and the temperature probe. Now I'm going to go ahead and start the temperature probe recording of the temperature of the water in that cup so that I have my initial temperature of the surroundings already going. I'm going to go ahead and select a couple of ice cubes from the bucket. Now these ice cubes have been sitting out for a while, so they should be at the melting point of water, which is 0 degrees Celsius, which is significantly colder than what is in the coffee cup. So the idea is that the stuff we are measuring is going to be about the water that's in the cup. So I'm measuring the change in temperature of the water. That's going to tell me how much heat goes into the ice cubes. And keep in mind that the heat from the water going into the cubes is going to do two things. First, it's going to melt the ice, and the liquefied remains of that ice are then going to have to increase in temperature up to the same final temperature as what's in the surroundings. So I'm going to go ahead and add these ice cubes in, close the lid, start to swirl so that there's good contact with the probe and everything inside of there. And then I'm just going to let this sit and transfer heat until I reach my minimum temperature. Now, I want to reemphasize that the measurement that we're taking is the temperature of the surrounding water. That is the water that we initially placed in there. Started out about room temperature, and now it's getting much colder as it loses heat to the ice cubes. So this initial temperature and final temperature that we're recording is telling us the change in temperature of the water we initially placed in the cup. And remember, the water is the surroundings here. So the delta T that we calculate here, along with the mass of the water that we put into the cup, and the specific heat of water, which is known, 4.184 joules per gram degree Celsius, or 1.00 calories per gram degree Celsius, that's going to allow us to calculate the Q, the heat that the water has lost. And that should come out negative because our delta T in this case is going to be negative. Just keep in mind that when we switch to the point of view of the ice cube, that Q is going to be now positive because the ice cube is absorbing heat. Now it looks like we are now starting to increase temperature a little bit, so we've hit our minimum, and if we look inside, everything is melted. So that is an indication that we are done with this process. I'm going to go ahead and stop recording, and that is going to save all of the data, and we can pick the maximum for the initial and the minimum for the final. Now this final temperature that we have recorded is also the final temperature of the ice in that cup. So it started out at 0 and then increased in temperature to the final temperature that we've recorded here. So when we transferred the ice in there, it started absorbing heat from the surrounding water. And when it absorbed heat, it did two things. It melted and it warmed up. So the Q equals MC delta T will allow us to figure out how much heat the ice absorbed to warm from 0 degrees Celsius to this final temperature. The remaining heat went into melting the ice, and that is what we're going to use to calculate the heat of fusion. So we'll do one last mass measurement so that we can get the mass of the ice that was put in there, and then we'll do two more trials for you guys to pull data from. This last mass will allow you to figure out the mass of the ice that was put into the coffee cup. So here we have the temperature readings. You see the 20.7 every half second. That's the initial temperature of the water in degrees Celsius. And then on the curve, you can see that dip down. That's when we added the ice, and it kept decreasing in temperature until 9.7 degrees Celsius, which you see at the bottom.